In my last video, for my 500 subscriber milestone, I featured a terrifying mixture of hydrofluoric and nitric acids. Aside from most of the noble metals and a few other exceptions, this mixture was capable of dissolving most of the periodic table. And then I thought, what if I could improve it by increasing the acidity? Okay, getting ready to mess around with HF again, and there are not fruit snacks in there. Definitely not. Sodium hydroxide solution, regular water, and that, oh, if that happens while I'm testing, holy shit, that would be bad. Okay, here we have boric acid. This is basically the weakest excuse for an acid that exists. You'd probably be fine if you accidentally ingested some of this. In fact, this acid is so weak it almost isn't one. Just look how slowly magnesium dissolves in this solution of boric acid. Part of this is due to poor solubility in water and other solvents, but it is very soluble in hydrofluoric acid, and when you add boric acid to it, it reacts to form boron trifluoride, which then further complexes with hydrofluoric acid to form fluoroboric acid, which is a strong acid. Okay, this is my solution of fluoroboric acid. I have crammed about as much boric acid into this hydrofluoric acid as I think I can get. So this is a strong acid. There are many different species of fluoroboric acid. One of them is a super acid. I don't think I've got that one in there, but the acidity is definitely strong. There's no denying that. All right, that is osmium and fluoroboric acid. It's no surprise that osmium doesn't react with this. It doesn't react with most things, actually, but that's not what I'm interested in. What I wanted to see is if tantalum and tungsten dissolved better or worse in a mixture with nitric acid. Okay, I have added a considerable amount of nitric acid to the fluoroboric acid. Okay, dropping tantalum in now. Well, that is disappointing. Next, I tried tungsten, and unfortunately this plastic bottle was so tall I could barely get the tungsten into the solution. Okay, inserting the tungsten, attempting to. Not a whole lot is happening. Doesn't appear to be dissolving either. At this point, you're probably wondering, what gives? Isn't fluoroboric acid a stronger acid than hydrofluoric acid? To better understand what's going on here, we need to take a look at what makes this mixture so effective. And it can be shown by this reversible reaction, which I think tells a lot of the story because it looks terrifying, especially the fluorine minus. That thing is set loose to exact its revenge on the material world. And I don't know for sure, but nitrosyl fluoride could also play a part in this. I don't know if it actually forms in this mixture, but if it does, that would make for a very powerful metallic solvent. Whereas with fluoroboric acid, the fluorine is too tied up and complex with the other atoms that it's not easily isolable in solution, even if it's mixed with nitric acid. And so I believe that's why it's just not as effective.